Welcome, mathematics students. Today I will be talking about triangles, but more about the relation of the side lengths of the triangles. But before talking about them, I want to start with how can we draw a triangle given three sides? To draw a triangle given three sides, we need a compass and a ruler. So here we are given a 7 centimeter, one side is 7 centimeter, the other one is 8, and the last one is 6 centimeter. So let's start with drawing that. First of all, we need a line segment, which is about one of the, you can choose one of the lengths, one of the sides, but I'd rather choosing the largest one. So let's open up our ruler, choose a line, extend it about 8 centimeter. So now what we have to do, we have to use our compass. So here you can see we have 7 centimeter, 6 centimeter. We have already drawn the 8 centimeter. So to draw this triangle, we have to open the legs of our compass about first 6 centimeter or 7 centimeter. The order doesn't matter. The basic rule is that you have to draw a triangle, you need to open your compass's leg about greater than half the length of our base. So we have 8 centimeter is our base, so it should be greater than 4 centimeter. We will talk about it later. So let's open our compass about 6 centimeter first. Okay, this is 6 centimeter. We put it on one of the edges. Now let's draw a part of a circle. This is enough. Now let's do the same thing for 7 centimeter. Put it on 0, extend it to 7, put it here. So here we end up with a single, above the base, we end up with a single intersection point. So now we have to draw the radii of these two circles. Not whole circles, part of circles. So put it on intersection point and put this on intersection point. So we end up with a triangle which has side lengths 8, 7, and 6. But let's measure them. This is 8, which is 6, and this is 7. So yeah, we did correctly. So this is how we could draw a triangle given three sides. But there's one catch here, is that how can we be so sure that the given three sides makes a triangle? To be sure about it, we use a thing called triangle inequality. Triangle inequality states that the sum of the two sides is greater than the other side. So here we can see that a plus b is greater than c, a plus c is greater than b, and c plus b is greater than a. Let's solve some example about this. So we have two sides, total of 6 sides given. Now we have to make sure, we have to check whether we can draw triangles with these three sides. 3 here, 3 here. So we have the first one is 3, 4, 5 centimeter. So first and first, let's apply the triangle inequality. 3 plus 4 is equal to 7, that is greater than 5. The second thing, for the second side, 3 plus 5 is equals 8, that is greater than 4. And the last side, the 4 plus 5 is equals 9, that is greater than 3. So the triangle inequality holds. Let's draw a triangle. First, draw the base. Let's make it 5 centimeter. And then now take our compass, open it 3 centimeters. Okay, 4 centimeter. Let's put it here on one of the edges and draw it. Draw a part of the circle. And now do the same thing for 3 centimeter. So we get the intersection point. Now draw the radius from the centers to the intersection point, and we end up with a triangle. Now let's check the second example. 7 centimeter, 8 centimeter, and 16 centimeter. Let's apply the triangle inequality theorem. So 7 plus 16 is equals to 23, that is greater than 8. 7 plus 8 is equals 15. But the thing is, it is 15 and it is not greater than 16. So we can't make this triangle. Let's see if we are correct. Make this 16. Draw our line starting from 0, 16. Take our compass. 7, 8. So here we see that we don't need them anymore, so we can delete this. So here we can see that we have two circles, but the thing is they don't intersect. So even if you drew the radii of the circle, we will see that we can form a triangle. So thanks for listening. Now I'm going to be talking about the Pythagorean theorem, which is also about the relation of the sides of a triangle. So hello again. Now I will talk about the Pythagorean theorem. But before talking about this, we have a triangle here. Before talking about the theorem, since we know algebra, I'm going to name this side. Since we don't know it, we can just name them whatever we want. I'm going to call this side A. Sorry, let me make this white. This side B, and lastly this side C. So this triangle is right triangle. Let me measure this. Yes, as you can see, it is a right triangle. So again, before talking about this, I'm going to get a few more copies of this triangle to form another type of object, another geometry shape we can call it. So by applying transformations and rotations, we are going to get this shape, which I'm building right now, this rectangle looking shape. So what can we say from here based on our triangles? We know that this side is A and this side is B. So the sum of them total one side of this rectangle will be A plus B. And now let's take a look at this side. We have again A and B. So it is going to be A plus B. Thus, we can say that our rectangle is actually a square. Another thing is that inside this square, inside our rectangle, we have another square. To show this, I'm going to take a square. I took a square from there and rotate it a bit, put it here, and you can see we have a square here. And from my triangles, we see that it has a side length of C. C, C, C. Each side length is C. Now we're going to take a look at the area of our rectangles. Area of our rectangle. So our greater rectangle has an area of A plus B times A plus B, since it's a square. So we can instead call it A plus B square. So, and another thing is that we can calculate the area that way, or another way is that we can add the areas of the pieces inside of our rectangle. So what do we have here? We have 4 triangles. Each area the area of a single triangle is equal to the A times B, the sides that are the sides A and B over 2. So AB over 2. And we have 4 of these triangles, so we will multiply by 4. And lastly, we have our rectangle, our square inside of our triangle, inside of our rectangle, a small rectangle. And it will have an area of C times C, which is C squared. Now we need to simplify this term. We know that A plus B squared is equals to A squared plus 2AB plus B squared. Sorry, b squared. And the right side is, when we divide 4 by 2, we get 2. So again, we have 2ab, 2 times ab, plus c squared. So we can see that we have 2ab on both left and the right side. So they cancel each other, and we end up with a squared plus b squared. That is equals to the c squared. So this is this a plus b, a squared plus b squared plus c squared is what Pythagorean theorem is all about. So we can say that if we have a right triangle with side lengths a and b and hypotenuse is equal to c, we can say that a squared plus b squared is equal to c squared. So therefore, in right triangle, this is how the sides relate with each other. So thank you for watching my video about triangles. Have a nice day.